Cool. Well, do you want to kick it off, Drew?
Yeah, of course.
Let's get to it.
Um, let's do it. Well, welcome everybody. It's great to see several faces here that and names that are close friends of the company. Um, so my name is Drew. I am on the engineering team here at Datum. So I'll kind of facilitate and walk us through a kind of a what we've been working on and what's coming up, and then Scott, who is one of our founding engineers, he's got a lot of exciting stuff that I don't want to ruin coming up. So, um, thanks for spending this time with us. If you're new to Datum, or just to remind you, if not, Datum exists to provide basically the internet superpowers, is what we call them, that you usually are reserved for, the hyperscalers, the FANGs, the large enterprises, stuff like private backbones, BGP, peering, dedicated connections, the data center stuff. It's usually reserved for them. We exist to bring that to the builders, to the platform teams, the infrastructure teams, the service providers. If you or your agents want APIs that can do all that stuff to create dynamic, secure, predictable connectivity across your application stack, no matter where it's hosted, then that's what we provide. A great example of this I always like to use is like your Vercel app wants to talk to your Supabase and also your ERP that's deep in the bowels of your enterprise VMware stack. That is our bread and butter. We want that to have a private backbone, just like anybody else would. So you can go to the next slide, Sylvia. So in May, we had our 1.5 release that we name all of our releases after, people who invented things. And fittingly, TimBL was last month. We gained a lot of traction on our connectivity, which I think is a interesting that he popped up for last month. Um, if you didn't know, we have 17 points of presence globally today on our network. Those use a kind of proof of concept, minimal cost, virtualized design. It piggybacks on NetActuate's Anycast and BGP. They're a close partner of ours. And over the last couple of months, we've been transitioning we've been building our native points of presence, our native POPs, and which we will be transitioning to over the next few months. It takes a while to do that. And we're going to start with kind of 3 core sites in the US, on each coast, and then, Dallas in the middle for good measure, as Shelby says, to give us a nice ring. And a lot goes into that, including working with our data center partners, designing the abstractions, really pushing forward, how do we want a network to look if we build it today, and really have no constraints other than, technology that we can find and hardware that we can buy. So we are really enjoying being able to kind of return to first principles and build everything from the ground up. And so a couple of really important parts of that is, what do we want from our underlay? What does that actually need to provide? What are our bare minimum requirements for what that means? And Peter, who's our network lead, has done a great job of kind of boiling that down to the essentials, so that we can sort of provide the right abstraction, but not too much, because we know that is, you can kind of get yourself in a tough spot design wise. And then we've modeled, I think Peter demoed this last month, kind of an early version of it, but we've gotten our container lab fully built out to model at least the early versions of that, which is open. So please feel free to grab that and play with it. On the Milo side, which is what we call our kind of business operating system. It's all the stuff that's super critical to actually running a business, but nobody wants to build, and you end up buying a bunch of stuff, and then you can't stitch it together because, no system has the same, same identity, or, any kind of cohesive tissue between. So we've also taken kind of a first principles approach to that and spent the last year uh, really building Kubernetes abstractions to have all of that natively integrated into our infrastructure. So the latest manifestations of that system are kind of cleaning up our activity logs, making those more easily consumable. We added feature flagging, and I'm really pleased with how we kind of came up with a design that's Kubernetes native and didn't bolt on, some external kind of service that solves a whole bunch of really interesting problems, but not problems that we really had. Um, and kind of foundationally, we finally have a service catalog, and that's if you picture a tree, that's kind of the trunk where everything grows out of it. So it's all of the metadata and the kind of origin for the APIs for all of the derivative services. So that actually took a while to get in there because we had to figure out what we were building first before we could catalog it. And then uh, how do we actually get money from customers? That is actually a tricky problem with a lot of different components. Again, you can sort of buy something off the shelf that will do it, but then now you kind of have to adopt all of the patterns and the processes that vendor decides that you need to have, and that's a really tough spot for something as important as how do we really go to market commercially. So last month we dialed in metering and kind of sketched in our payments flow. And so that is really important. As many of you know, we all use cloud services every day. It's kind of composed of two components. You consume a bunch of stuff, and that gets counted, and then later on you get a bill which puts some dollar amount on top of the stuff that got counted, and then you get charged that amount. So we need the same thing. We also are a cloud. And so we've partnered with two providers, Amberflow and Stripe, for kind of the heavy lifting there. We don't need to reinvent, how to get credit cards and how to, count numbers. Like Amberflow does that really well. But we do need it natively integrated, and so that's what all that work was about. And so kind of did the initial end-to-end pass through that, and now we're working our way through the long tail of actual services, and what are the things that we meter as a part of consuming all of the stuff that we offer. And then for Datum Control, which is our command line interface to Datum Cloud, we added the ability to have plugins. And I'm going to actually not say hardly anything about this because Scott's going to do a great job of that in a few moments. And then kind of the plugin that we want to dive into today, which is compute. Any questions? I know it's kind of fast, kind of a whirlwind, but I want to leave room for other things. Any thoughts? We've got most of the team here, so if you have any questions,
Uh,
it's a great time.
on payment, are you looking at like localized payment like in Europe, like SEPA based payment, skipping the whole credit card payment processes that you have behind Stripe?
So not in the initial phases, but we certainly want to, you know, we want to make it easy for people to pay regardless of where they are. But that's a little bit further down the road.
Okay, and is via partners, like via distributors, also going to be an option? Because that's where most of the contracts are going through, anyways. If you look at like EMEA
Right.
and outside the US.
Yeah, I'd say that we are only focused on sort of SaaS style payments from the website right now. So that's why we're laser focused on credit cards. If we fulfilling a contract or some kind of larger deal, like we can obviously make that work. It's just not integrated into the software stack right now. Does that answer your question?
No, no, it's okay.
Yeah, great. Steve, do you want to add anything to that? Does that sound about right?
No, that sounds right to me. Yeah.
Awesome. Hey CJ,
Hey,
I see your hand.
yeah, quick question on the metering. So from a like SaaS billing perspective, are you guys thinking about like what levers are going to be put into the actual is it going to be like I'm assuming subscription based? Is it going to be like egress data? Is that like the main lever that you are like actual like packets flowing through the network? Is that like the main billing lever? How are you thinking about like what items go into the subscription?
Yeah, that's a great question. We are we're building the tools so that we can decide what to meter on, and
Hmm.
that's tightly related to our costs and how we actually have to pay for backend infrastructure. There are things that we will happily subsidize in order to help people have reach the outcomes that they need to. So it's a little early to tell exactly how we're gonna charge for that.
Yep, that makes sense. Thanks.
But I will say, like, the capability to do that and to meter on that is absolutely part of the system. Awesome. Any other questions?
Hey Drew, are you running your own hypervisor, or are you spinning up those virtual machines within your kind of NetActuate and other partners' hypervisors?
So currently, our virtualized POPs are piggybacking on NetActuate's hypervisor. So we just use their, kind of commits on their regular VMs.
Cool, thank you.
We do have bare metal with servers.com. So we've got a handful of machines there that we're moving compute to, which, we'll talk more about that in a minute. So that's kind of our intermediate phase. So we're, kind of moved to bare metal in places that we need, while we also build out sort of our core sites, which are primarily going to be network sites. They might host workload down the road, but they're mainly going to be for tethers to wherever the workload is, which will be in servers.com for the foreseeable future. Awesome. Well, thanks for the questions. Before we talk about next month, I wanted to do a deep dive into compute. So, team's been super hard at work working with our partner Unicraft, and I think Scott's going to tell you a lot about that. So, I'll just hand it over to you, Scott.
Cool. Yeah, so last few weeks we've been hard at work augmenting our compute offering to support our own bare metal in the future. But right now we're just virtualized on top of an actuate. Uh, our goal is allow people to easily deploy workloads across a diverse set of locations, with the idea that they can provide selectors that determine where workloads get placed, whether that's latency sensitive work locations, or locations that have GPU capacity, or locations that have some other constraints that they want to declare and for their application. We've also added support for doing advanced configuration of workloads. Configuring services is easy when you're on a VM, but it's important to be able to mount in configurations and secrets to the file system, or expose them as environment variables. We are doing just container-based runtimes right now, but plan to add VMs on top of this in the future. And yeah, like Drew mentioned, it's all powered by Unicraft under the hood. So they're able to build unikernels off of OCI images and make those deployable to their edge runtime. And so we've so far been able to prove out that we have support for really all the popular application runtimes: Golang, Rust, Node, PHP, Python, a few others in there as well. Just really haven't gone through the paces of actually validating those yet. Before we get into how we actually built it, I figure I'll take you through a little demo first. Sylvia, if I can take control. No, actually, this might be too big. Let's start here. Okay, so just to see my IDE, as part of this demo, I wanted to be able to prove out something real. We have a big goal of running our own stuff on top of our compute product. We want to make sure we're actually building something that is usable for us and also others. So one of the first easier use cases is moving all of our Node.js based website deployments for Milo OS or Datum.net over to our compute. They are pretty simple static websites. They do have API integrations with things like Strapi for CMS. So they need things like API keys mounted at runtime so they can actually authenticate with those external services. Or in the case of Milo OS, we actually integrate with GitHub. And so what I did first was I actually built out a new Docker file that is specifically tailored to creating a unicraft or a unikernel deployment of this Node.js application. So it does the whole bundling with ebuild, esbuild. It builds from a scratch image, pulls in the Node.js runtime and the generated distribution file from the build pipeline. And then there's another file in here called the Kraftfile. And this is what unikernel or Unicraft uses to actually build a unikernel OCI image that we can publish to a registry. After that, it's really going through the process of configuring the application. And so we went through this a long time ago, but it's back now. So there's the concept of a workload. A workload defines really a template for your application. So that's where you have the template down here that shows how you're actually configuring the application, the size of the image that it should be using, the image that should be used, any configuration files that you want to pass in there. So in this case, I'm exposing an environment variable to the application and pulling the value from a secret that I have configured in the project. If you're familiar with Kubernetes, it all feels very similar to that. It all works very similarly. It just allows you to declaratively define how to configure everything. And then down here, there's the concept of placements. And this lets you define where the application should be deployed. So for this example, I'm just going to do one replica in DFW, but I could define multiple locations here if I wanted to. In the future, we also want to support more than just like city code selectors, but really do like label value selection across like locations and how you, based on like the capabilities those locations define. And then I also included just like an example of like the secret manifest that should exist within the project. But before I actually kick this off, anyone have any questions? Okay. So just going to prove out that I've got a secret in here. So if you've used Datum Control before, it looks and feels very much like Kubernetes. We added a new context command recently that shows you all the contexts that are available to you and allows you to select a current context. And so for now, I just have my Datum Cloud project selected. So any command I do is actually executing against my Datum Cloud project. And then here you'll see secrets. I have a Milo OS secrets, which contains our GitHub authentication credentials. And I'm going to use customize to actually build the workload manifest. Sorry, I've got a cat. And we're going to do datum control apply -f. And so this is actually going to apply this workload manifest to my project. And in the background, our control plane will start spinning up these instances across our locations. So if I do datum control compute instances now, I see there's a single instance available in DFW for my Milo OS site. And let me swap to a browser. And if we open that URL, we'll see the Milo OS website deployed on top of Datum Compute. The nice part is it came up in all of a couple seconds. I'll show you a bit more on this side.
That deserves some clapping.
Yeah, so it became available in around 5 seconds right now. We do plan on making this a little faster in the future, but I played around this the other day and I sequentially spun up, I think it was 10 replicas of an application deployment in under 30 seconds, which was pretty wild to see. Very used to like the GCP world where it takes like, 5+ minutes. Okay, so
And we should point out that the underlying technology, the actual unikernel starts in 10, 15 milliseconds. So there's a lot of optimization to be done here. We can get it probably sub-second.
yeah, so yeah, we'll get into the architectural side after this. But we did make a lot of progress on just like some foundational pieces within Datum Control. We really wanted to prioritize a CLI first experience for compute because uh, if you're familiar with deploying applications, especially complex ones, clicking through UI is not the best way to do it. Click ops as it's called. But being able to define a workload manifest that you can use within version control and deploy it repeatably in a CI pipeline, it's definitely the way forward. And so we wanted to prioritize a really good CLI experience. Now, we did add support for all the raw Kubernetes commands, so get, apply, update. Those all work out of the box, but they're very generic features that are applicable to all services. But we want to be able to do something that's like more specific to compute. That way, you can do Datum Control, compute, deploy, and have a more like wizard-like experience on the CLI to actually deploy an application. One of the big things we didn't want to do was actually like bake this compute functionality into Datum Control because we believe that it should be very easy to extend our CLI or experiment with how things are represented. Brett recently was playing around with, well, what if you had like an AI wizard inside Datum Control, and initially we had to bake that in, but it'd be nice if anyone can try to extend Datum Control and have a good foundational plugin to get there. And so if you do Datum Control plugin search now, you'll see all the official Datum Control plugins that are available and the latest version of that plugin. You'll also see if you do list, you can see ones that are installed. You can upgrade them, install ones that aren't in our official registry. There's a lot you can do with it. But the nice thing is it allows us to easily extend the experience and make it what everyone else wants. And internally, it just like execs out to a Datum Control plugin. So these can be written in any language that you want. Doesn't have to be Golang, and they can securely retrieve and access credential from Datum Control to use for things like API communication and things like that. Okay, we can go back to slides now.
Amazing, Scott. It's difficult to overstate how much technology is in that very simple demo.
Yeah, let's go to the next slide and go through kind of like the control plane architecture of how this all works. And so we've tried to move towards this idea of a cell architecture where each of our edge locations has a separate control plane from other locations or central control plane that users actually interact with day to day. A big reason for this is we want locations to be kind of self-serving, so they shouldn't be reliable on a centralized control plane being available at all times to auto scale or do standard life cycling things within location. And so what we have is very left side is the what we call project control planes. It's a project that you interact with that contains all of a consumer's resources, things like workloads, networks, HP proxies, whatever you're using. And when you create a workload, it's going to look at all the placements within that workload and create individual workload deployments within Karmada. If you're not familiar with Karmada, it's a federation tool that lets you federate resources from one single control plane into many control planes. And so all of our edge locations have a Karmada agent installed in that control plane that just connects to the centralized Karmada control plane and syncs resources down. Once a workload deployment gets into an edge location, the compute operator in that location takes that and starts trying to actually spin up instances for that workload. So if it says that it needs a single instance, it's going to create that instance and let the rest of the platform actually provision that instance's infrastructure. So it's going to use the quota system to confirm that they have memory and resources available to consume from their project, making sure they don't go over quota and have capacity available. It works with our galactic networking runtime to get IP addresses, do BGP advertisements, and connect into the SRv6 network. It is a little forward looking yet. We are working towards VPC integration, not quite there yet. And then it works with a tool called Kraftfile, which is a project by Unicraft that provides a K8s compatible interface into their platform. And so they look for pods scheduled to a Kraftfile node. It works as a virtual kubelet instance. And all that does is it takes the pod manifest that you specify and creates a Unicraft instance for that with whatever configuration you want in there, whether it's mounting in secret, it's image pull credentials, whatever the pod manifest looks like, it just converts that to the Unicraft example. And it goes through all of that in just a matter of a few seconds. So it's pretty cool seeing it working. There's definitely some places we got to optimize. There's still a lot of functionality we're looking to add to this, things like auto scaling. We'll get into that in the next slide. We can go to the next slide. And so yeah, I just wanted to highlight Datum Control plugins are here. It's very nice having the ability to easily extend Datum Control without making it officially baked in, or even offer the ability for third parties to write plugins. So that way, if anyone from the community wants to contribute a plugin that says, hey, like this is a really cool way of navigating Datum from the CLI, there's an easy opportunity for them to extend that without having to bake that in. And then we've got a really cool plugin model. It's heavily inspired by the Kube Control Crew plugin architecture. So it does support any runtime. And we are actively working on Datum Connect, which is going to be a Datum Control plugin with headless tunnels coming soon. And then if we go to the next slide, we've also been making a lot of work around our service catalog. Kevin touched on this briefly in the last call, but the service catalog is becoming the single pane of glass into how consumers are consuming services across our platform. It's where anyone can get information around the metering data that is collected for a service. It gives you insight into the quota limits that are put in place. So how many workloads you can create, how much VPC CPU you can consume, memory, etc. It's also going to have a lot of information about pricing and how much you're expected to pay for a service. And one of the nice things is it also gives us the ability to do private enablement. And so if we bring a new service to the platform that we're not quite ready for everyone to touch, we can easily just configure it and say, hey, this has to be approved for someone to use it. They can submit a little form saying, hey, I want to use this. We get a notification on our side. We can just say, yes, you're allowed in the door, and you can start playing with it. And from a control plane perspective, it also gives us a really good point or integration point where once someone actually enables a service like compute into their project, uh, we can see one that they enabled it. We can collect feedback around why they're trying to use it. But it's also the trigger point for our control plane to set up their project with granting our components access to pull resources like workloads and other things from their project, and also gives allows us to install grants in their project as well. So that's how we do quota enablement, metering, billing. It's all driven through this easy to use service catalog. And I think I have one more. So we've been heavily focused on just getting the compute offering running in a test location right now, but trying to prove the end-to-end flow of making sure we can actually deploy compute in a diverse set of locations. And now that we've got a lot of the foundation in place for the control plane side, it's really just enriching features in what compute can do. So being able to do integrations with our Galactic VPC, so we can do private networking between instances, integrating with our Envoy Edge, integrating with Datum Connect, IRO tunnels, deploying on top of our own bare metal infrastructure. It's all the good things we're starting to work on next, along with improving debuggability, getting container exec type functionality and observability, making sure people can pull logs, understand what their application is doing, what performance is like, start times, CPU utilization, memory, etc. I know I went through a lot there, but any
Go
questions?
back real quick, Sylvia. We've got a couple of questions, Scott, from the channel. Eric was asking about sort of usage and how to dynamically scale based on different criteria. So what sort of load balancing health checks could I use? My goal is to spin up more instances upon 75% CPU and route traffic to less used instances.
Yeah, so we haven't gotten quite to load balancing yet. But I'd say any sort of load balancing that you'd expect from major cloud providers. So, round robin or least used connections, I think you can expect once we get to that point. From an auto scaling perspective, I think what we initially will target is, the easy CPU utilization or memory-based auto scaling. But I definitely want to open the door to custom auto scaling, so that way your applications can advertise telemetry and you can use that telemetry to trigger auto scaling events. That way, if you're running, let's say, some sort of queue service, you can actually auto scale based on like queue backlogs instead of just simple metrics like CPU utilization and memory, because that's helpful for a lot. It doesn't cover all the needs. Did that answer your question?
Yeah, I imagine we'll have.
I got another question for you, Scott, actually. So you talked about the quota system and stuff during the boot up process, and you showed that in the diagram about like how we use that to, measure if you're able to provision things and stuff like that. How does it work once things are provisioned? Like, do we have some sort of subscription there? Like, if we revoke the once you have the thing up, or if you go over your memory, once you have the thing deployed, is it like, how does it check that you're not over consuming at that point?
Right. Yeah. So what we do is when we're creating your instance, we make a claim against the quota system, and it says, "Hey, I want to claim one instance. I want to claim, let's say, 2 CPU and 4 gigs of RAM." And the quota system is going to say yes or no to that request. And if that request has not been satisfied yet, the instance sits in a scheduling state where it advertises to the user, "Hey, really, I'm trying to get this thing provisioned, but you either don't have quota capacity that lets you actually do this, or still waiting." Normally, that happens within a few hundred milliseconds, I think, if not less. So it's pretty transparent to the user. But once it's been claimed, even if we scale the work instance down to 0 because we're not actually passing any traffic, the quota system is still acknowledging that you're holding on to that CPU in memory for that instance. And so the instance is able to scale up and scale down based off traffic patterns without actually interacting with the quota system itself. It also means that we won't ever over provision capacity because an instance won't actually start on the runtime until the quota claim has been granted to that instance and says, yes, you are actually allowed to use the number of resources that you've requested.
I see. So that works well for like allocation type things. And with rate, is it similar, but we just do that math like in line or something? Like how does like let's say we say you're allowed to do X many requests per second or whatever.
Right.
How do we make sure that to enforce that from from our standpoint?
We don't have rate-based quotas today.
Okay. So yeah, from an allocation standpoint, it means once you have it, you have it. So okay,
Right.
that answers my question. Thanks, man.
Other questions?
Is that Unicraft? Is this like unikernels back in Docker days? Like you run C and stuff.
It's separate from that. The Unicraft team has been working on unikernels for years now. Some very focused research has gone into it. And then there's also parallel efforts to operationalize micro VMs like runc and there's some other companies that are bringing that to market as well.
Okay. And are you guys looking at like this? Have you heard of Forklift, which is just a tool to literally forklift your VMs off of VMware or from VMDKs to QMUs? Are you looking at also this where the net kind of workload that could go on these unikernel kind of VMs could be coming from classic VMware workloads?
Yeah, we haven't tried to tackle the migration use case yet, but I know the Unicraft team, has thought long and hard about it, and we'll figure out how to make that something that we can support at some point.
Okay. I got one last one. So how much of this is like coming from the old Packet.NET day? Remember like TimBL and all that?
Yeah, that's a great question. So none of this is actually it doesn't share any actual code with Packet or Equinix Metal. This is all net new stuff that we've built. It does share some DNA though, and we certainly are looking at Tinkerbell as the leading candidate to handle our bare metal provisioning. We just haven't needed to do that yet.
Okay. Cool.
Yeah, for sure. Felix, you had a question. Scott answered it. Oh, yeah. Yeah. So the Datum compute functionality will be completely contained within the Datum ecosystem. Unicraft is just providing the unikernel technology that powers it. All of the sort of commercial and operational aspects of it. The runtime is all owned by Datum. CJ, let's see who had a question about the Yeah, CJ, you were asking about the node runtime and what dependencies are included there. Scott, I don't know if you want to elaborate on sort of the difference between our full, like, you know, building a JavaScript image versus, you know, running a function serverless.
Is the question around like what's included in like a default Node.js runtime?
Yeah, so I have like a ton of bun apps
Mhm.
that I would love to just, there's a lot of them that are just very serverless in nature and similar to like you talking about the Vercel model. It's like, here's my app, just go run this bun runtime app versus building a container. Um, just curious about the opinions in that deployment model.
Yeah, I think Vercel does a good job of abstracting the whole build and deploy process from application users. I do think we'll get there eventually. Right now is a lot more focused on just getting the underlying compute foundation in place, and then we can start working towards the higher level abstractions around like offering serverless runtimes or just a kind of more of a connect your GitHub repo to your Datum project, and like we'll handle everything from there. But with the actual runtime itself, you can put anything you want into it.
Mhm.
It's just a matter of uh, building up the right Docker image that can convert into a unikernel that's deployable, all by itself.
Yep, that makes perfect sense. Cool.
Yeah, and it's important to point out, in case this hasn't come across before, that these are fully isolated kernels. It's like it's a full Linux host. It uses a container to sort of bootstrap the build and handle dependencies. But this is a fully isolated machine that we can, you know, plumb network connections to, and it has its own process space. It's not just like C group, separated. Another question from CJ, and then let me do Christian first. So he asked Scott about dynamically scaling instances and how quotas come in there.
Yes. So when an instance is auto scaled in a location, it goes through the same process as like workload creation. So the first step of it is, go and claim its resources from the quota system, make sure they have, CPU and memory available to consume. That is like the one uh, point right now where we are reliant on like a centralized control plane is just for quota allocation. So we can track capacity across every location and not just individual ones. But everything after that is totally within the location itself. Uh, Networking will provision right after that, and then the instance will be booted.
Thank you.
Yeah. CJ, you had your hand up.
I was typing as well. But just curious, that compute environment with how that's architected, you're almost able to kind of offer like full sandboxed environments and start competing with like Daytona. Is that kind of generally what you're thinking, or more focused on the app orchestration?
Yeah, I mean, we certainly are wading into the agent sandbox world, and we certainly this capability certainly can service that use case. But it's not our primary commercial go to market. That's not, we're not trying to compete with our partners there. We want to help them and be the foundational support from a network standpoint. This is purely more oriented towards network use cases and internal use cases, and people that aren't consuming these other services, but they do need some compute. It's just very hard to have a cloud without the three-legged stool of network compute and storage. Storage is the easiest one to sort of uh, to outsource, right? Because you really just need to usually have to connect to an endpoint. Compute and network are more tightly integrated. And so we really needed this functionality in order to be able to build a lot of other things. And so, lo and behold, we'll let others use it as well. But it's not our primary it's not the primary thing that we're trying to sell. In fact, we'll probably, make it very attractive from a pricing standpoint. Great question. Okay, Sylvia, let's go to the next slide and we can talk a little bit about what's coming up, which really is a lot of what we've already been talking about. So fittingly, the next month is our 1.6 release is named after Katherine Johnson, who is a famous, she worked at NASA for many years. She was instrumental in the moon landing. She was one of the first, computers who used to be a human before they were machines. Brilliant woman. So she's a fitting representative for our June release. Sylvia's working on it. We're gonna, Scott gave the primary part of the release, which is really operationalizing compute and making everything you just saw a lot easier to consume, running on our bare metal, and where you can actually operate it and observe it. We also have Unicraft has a feature that is in the works, which is essentially a way of it's very similar to ephemeral containers, where you can join a VM to another VM, and they can share. They can talk to each other like they're adjacent processes, and so, but even more so than containers, you can actually manipulate the host. So what we want to use this for is for pre-plumbing network connections. So, hey, instead of you having to install like an IO dependency chain to build a tunnel yourself, we could actually just, plumb that for you on the machine. So it comes up with, connected to your private backbone or to your storage layer or whatever it is. They haven't quite finished building that, so I don't think that will actually land this month. It's probably going to be later in the summer, but it's pretty cool. Pretty excited about it. The billing work that we talked about at the beginning, that's making great progress. That should be available by the end of the month. And then we're also, like Scott said, we are adding another plugin to Datum Control for our connector ecosystem, which right now you actually can use those if you download our desktop app and you create a local tunnel on your Mac or Windows machine. It will, or Linux, it uses this underneath, but there's a lot of cases where you don't want a desktop app. You actually are, you have a headless machine in a data center, in a closet, or a VM that you also want to expose on a public. You want to expose something on localhost to as a public endpoint. You'll be able to do that with the tunneling capability built into Datum Control. And then as far as our sites go, like I said before, this won't be all the way finished in June. This is going to take the rest of the summer, just because we have, we're dependent on the data center world, which, as many of you know, is not as fast moving as a lot of people would like, which is why Datum exists. But that's okay. We are doing that on your behalf, and so we're working with our partners there to get our sites up several weeks. That is all we had for today. Any other questions or comments? Awesome. Well, it was great to see you all. Thank you for joining us, and we look forward to next month.